Hey students, we're going to go ahead and formulate again quadratic and linear systems of equations. So in this problem, we're going to now carefully decide which solution they're finding based on the keyword right here, ascends. So let's go ahead and read the problem. Josh and Isaiah are experimenting with some new flying objects. Josh has a drone and Isaiah has a rocket. Josh sets his drone on the top of a 2-foot tree stump. He begins flying the drone and it ascends at a constant rate. So that's what creates that line right there. The rocket launches from the ground with an initial velocity of 80 feet per second. After how many seconds are the drone and the rocket at the same height as the rocket ascends? So rocket is ascending and then descending, meaning we're looking for this intersection right here. So what do we know so far? Well, we know we need a linear and a quadratic. We know we're not given the equations. And also we know that the drone was set at on top of a 2-foot tree stump. That means that it's not starting at 0, it's starting at 2. And that's what we see here in the graph. Also, we are given the velocity. That means that for a quadratic, we're not going to have to create regression. We could just use the initial velocity of 80. And then the initial height. As mentioned, the rocket launches from the ground, which means it's 0. So with these two pieces of information, we can just use the equation of negative 16x squared. Again, this equation is based out of situations with gravity because it just pulls down, and it always works with that negative 16 as the a value. So we're going to replace these two values with 80 and 0. And we're going to end up with y equals negative 16x squared plus 80x. And then we just don't put plus 0 because we don't really need it. So this is the equation for the quadratic. For the linear, we do have a line with 2 points, which again, we can create an equation of mx plus b by calculating the slope and identifying the y-intercept. So in the graph, the y-intercept is 2. It's above the 2 feet tree stump, so we're going to put a plus 2. And then for the slope, we need to find that rise over run or change of y over change of x, where the formula works, but also like a mini table can help you visualize the change of y over change of x. So 0, 2, and 4, 8 are the points. Change of y will be adding 6, change of x will be adding 4. So slope is always change of y over change of x, which means 6 over 4, which if we simplify, that will be 3 over 2. Now, because it's real world situation, it's okay to turn that into a decimal. Only if it's a repeating decimal, you might want to just stick with the fraction. So we'll say it's 1.5. So y equals 1.5 x plus 2. Alright, so these are the two equations. We're going to go ahead and graph these in the calculator now. Okay. And we're going to just type 1.5 x plus 2. Press down and then type negative 16 x squared plus 80x. And again, it looks like it's somewhere in there, so we're just going to go menu, analyze, intersection, and it's that solution right there. So let me write that down, 0.026, comma 2.04. Alright, so then if this is your solution, we just need to interpret this in terms of the situation. If this is x and this is y, according to the graph, time is the x and the height is the y. So the question is, after how many seconds will the drone and the rocket be at the same height as the rocket ascends? We will just say at 0.026 seconds. Okay, I hope this video helps.